Now we're going to start looking at the QTI sensors and a simple line following algorithm that you can do with your BOE-Bot. So the first thing we want to do is we want to add the QTI sensor, we'll just add one, to the BOE-Bot. And then we'll take a look at the theory of operation of it, and then we'll actually write a program to use it and look at how we can actually detect colors of the surface of what the BOE-Bot is on. So the first thing that we should do, or you should do, is you should add one of these QTI sensors. Okay, and so if you look at this picture, let's just start with one. We're just going to put one QTI sensor down and just look at whether it can detect light or dark. And you're going to use the 1/7 inch screw provided with the QTI kit, and then there's an unthreaded spacer, a threaded standoff, and then there's a 3-inch screw. But go ahead and put an extra nylon washer in there that comes with the kit, and that's just going to get the sensor lower to the surface. I've noticed that it actually works a little bit better if you just put that nylon in there. Go ahead and center it in the frame right here, and it's going to come with one of these red, white, black cables, the same cable that you use for your servo motors. And you're going to run the wiring up through the grommet, and then you're going to insert it into your breadboard. The way that you do it is you use this little 3-pin header that it comes with, and you'll actually put the 3-pin header in your breadboard, and then you can jumper wire to +5 ground and an input. The way you should wire it is the white should go to +5, red should go to, let's use the pin 2 of the Arduino, and then put the black one to ground. Now be very careful that this is not the same cable, or this is not the same pinout as the servo headers, so you can't plug it into a servo header and use one of those. They have the white and the red swapped. Okay, so we first need that, and then let's talk about how these sensors work. Okay, so QTI stands for Charge Transfer Infrared. Okay, and this little sensor contains both an IR emitter and an IR receiver. And IR stands for infrared, so it's electromagnetic radiation that's above the red in the spectrum. Okay, so it's basically it's a electromagnetic energy that you can't see, but it's there, and it's what we use to detect. It's essentially heat. Okay, but it's really neat because we can generate this pretty easily, and we can build detectors that can see this. And so what you're going to see in here is you're going to see 3 pins, red, white, and black, and you're going to see 2 different circuits that sit within here. What you want to do is you want to wire, like we said, the white to +5, red to pin 2, and then let's do the black to ground, and go ahead and use these cables that are provided. But again, remember, you can't plug them into the servo headers, so use a 3-pin jumper. And then let's think about the way that this works. When we wire +5 and ground to the cables of this little guy, what happens is that you are essentially putting +5 through a resistor through this IR diode to ground. So it's always on, it's always transmitting. Okay, so you can think about 2 separate circuits where the transmitter is just on and it's never going to turn off. So we have no real control over it once we wire it up. The receiver is going to be connected in series with a capacitor and this transistor basically. And the way that this works is that when it sees IR energy, IR radiation, it will allow more current to flow. So it'll cause current to flow. When you are looking at the receiver, you don't care about this resistor and the diode over here. It's just always on, and you can just ignore it. And what we do here is we just concentrate on what's going on right here. The 220 ohm resistor is in series with the IO pin, but it doesn't necessarily impact the circuit. It's just there to kind of limit some current. We're really concerned about this capacitor in series with this IR detector, and this IR detector is going to essentially look like a resistor. Okay, so when it gets IR, it's going to allow more current to flow, which means that its resistance goes down. When it doesn't have IR, it's going to not allow current to flow, and it's going to have a high resistance. So we can essentially get this basically down to an RC circuit. So that's the way that we're going to detect the IR. And we use the fact that IR energy is absorbed by different colors. Okay, so for example, if you put IR energy out into a black surface, the black absorbs all the infrared energy. Okay, so nothing will actually be reflected, but white will reflect it. Okay, so if you have a transmitter, which we do, or an emitter, and it's always on, it's going to be pumping out this IR, and then it will, if you hit a black surface, nothing comes back. If it hits a white surface, it will come back, and luckily we have a receiver or a detector sitting here that will observe it. So since we know we're outputting this IR, we can essentially determine whether the surface right by the sensor is either going to be light or dark. And we use this for things like line following. So if you put like a black piece of electrical tape down on a white floor, you can put the sensor right over it, and you'll be able to detect whether you're on the white part or the dark part, and you can essentially steer to follow the line. Okay, so if you think about, let's look at the case where you're over a black circuit, nothing is being bounced off of the surface and coming back into the detector, and so what will happen is that this little IR transistor right here, it will not have current flow, so there's nothing really flowing. But when you do reflect it, it hits this, and this little phototransistor is going to allow a lot of current to flow. The reason that this is important is because since the sensor itself has a capacitor on it, and so we're limited with what we can do. It's basically designed to essentially look like an RC circuit. So what we really want to do is we want to charge up this capacitor, and then we're going to manually charge it up, and then what we're going to do is we're going to allow it to discharge, and we're going to discharge it in an RC circuit fashion. The capacitor is actually in the circuit itself, so it's this little fella right here. It's this 0.10 microfarad, and the resistor in the circuit is going to be the phototransistor, or the IR transistor. Whenever you have a passive RC circuit, the discharge follows an exponential decay of e to the negative t over RC. Okay, so what's going to happen is that if you have a lot of absorption and there's nothing coming back, this transistor, so you're on a black surface, this transistor right here is going to not allow a lot of current to flow, and so it's going to have a high resistance. So that means the R is big in that exponential decay, and it'll slowly discharge, okay, or slower than normal, okay, which normal being kind of right in between the two. Okay, then if you looked at this situation, you're going to have a lot of IR coming back into the sensor, and this IR transistor is going to have a lot of current flow, meaning that it's essentially its resistance is low, and it's going to have a faster discharge. So what we can do is we can take advantage of that, and we will actually take pin 2 of the Arduino, and we will charge up the capacitor, and we're going to do it by just writing a high to it. And then we will turn that pin from an output to an input, and then we will allow the thing to decay. And the rate at which it decays is going to matter depending on what color of surface is right next to the sensor. And it's pretty awesome because you can see it in real time. So in this situation, we're above white. So everything is being reflected, and notice that it's charged up. We charged for 1 millisecond here, and then all of a sudden you say, okay, go. Well, you're above a white surface, that IR transistor's on, it's pumping, it's got a really quick discharge rate. Over here, you're above a black surface. There's no IR being bounced back into the detector, and so what happens is that IR transistor is not letting current go, so it's got a high resistance, so it has a very slow discharge rate. Now, how do we use that? Well, this is a digital device, and the way that the Arduino works is essentially above 1.4 volts, it reads it as a high, and below 1.4 volts, it reads it at as a low. So if you can see this little red line here, that's about at 1.4 volts. And if you think about after we discharge, what if we waited like 1 millisecond and then we read? Okay, so in both of these situations, both of these plots right here, I waited 1 millisecond and then I read. Notice that in the situation where you were above a white surface, it had discharged to a 0 immediately. So it went below that 1.4, and you're at a low. So if you read right there, you'd see a 0. Over here, though, if you're above a black surface and the thing is slowly discharging, it hasn't discharged down to a 0 yet, or to a low yet, and so you would actually read a 1. So that's how we're going to do this. This is the theory of how we're going to do this. Is we're going to create a program, and we're going to essentially charge up the capacitor for just a millisecond, okay? And then what we'll do is we'll turn the pin to an input, and we'll wait a millisecond, and then we'll read from the sensor, and then we'll see what we get. Okay, so let's go ahead and let's do it. Alright, so the first thing I'm going to do here, let me clear this out. First thing I'm going to do is I'm going to start up a new Arduino Sketch, and I already have my my sensor on there. Okay, so you can see my sensor right here. Okay, so there's that little fella. And you can see I've got it wired up. I've got my 3-pin header coming in right over here into pin 2. I have an oscilloscope connected to it right here, but I still have my whiskers on there and everything, and then the little baby's down there centered right in the middle. Okay, and then I have a piece of paper with, I just put a piece of electrical tape on it so we can kind of determine this surface that we're above. Okay, so here's what I want to do. Let's start up a program and let's fire this baby up. The first thing I'm going to do is let's get our serial monitor on so we can watch what's going on. So I'm going to do a 8600, and then we'll go serial print, line testing QTI sensor. Okay, and then let's delay. We don't even need a delay. We can play a tone since our piezo speaker's on there still. So let's go ahead and play that for, I don't know, half a second, and then delay 500 to let it sit there. And now I'm ready to go. Okay, so what's interesting about when you use this sensor is everything's in a repetitive loop, including the way that you set the pins up, and that's because we're going to be changing between inputs and outputs on pin 2 over and over, and that's perfectly fine, but we're going to put it into a loop. Okay, so the first thing we want to do is we want to turn the IR emitter on for 1 millisecond, and this is going to charge up that capacitor. So the way that you do this is, the first thing we have to do is do a pin mode. Pin 2 is where we connected the red of that little sensor, and we're going to make it an output. Okay, and then let's drive a high. So all we do is do digital right pin 2 high, and then we just need to delay, and we're going to delay for 1 millisecond. Okay, and that's going to get ample time for that capacitor to charge up. All right, now here's what we got to do. We're going to turn IR. It's not turn IR emitter on. It's basically charge capacitor. That was way better. Capacitor for 1 millisecond. Okay, the thing's already on. The emitter's already on. Then what we want to do is wait 1 millisecond and let capacitor discharge, and it'll discharge quickly if it's over white. It'll go slowly if it's over black. So what I'm going to do is I'm actually just going to go, okay, pin mode, pin 2 is now an input, and as soon as it flips to an input, it's not driving that capacitor anymore, and we're good to go. And now I just want to delay for 1 millisecond, and then now I want to read it. Okay, read pin 2, and I want to see what's happening out there. And I'm either going to see a high or a low, but remember how we do a read, we need to set up a new variable. And so I'm going to create a variable that's going to have a type byte, and let's call it sensor 1. And that's my variable, I just made that up. And then I just do a digital read from pin 2, and that's it. I'm done. So now what I'm going to do is let's just print this baby out to the screen and see what happens. So let's do serial.print line, and I'm just going to put sensor 1, and then we'll delay 50 milliseconds, and then do it all again. Okay, so let's go ahead and fire this baby up. Okay, I'm going to go, oh, I skipped my first step that I always do. I just got to save this. So let's go back and save this into our working directory that we have. So desktop, and I'm doing Arduino, and let's call this QTI test 1. Okay, all right, and then let's go ahead and fire this up. I'll bring over the serial monitor while we're sitting here, and now we wait. Okay, so it's going to be working. Compiling Sketch. And it's working away. Okay, so there it goes. All right, and now it's writing. Okay, and so I come over to here, and one of the things that I'm going to see is I've got my paper. It's actually hitting this brown on the desk, and it sees a 0. Watch what happens when I put it on white, nothing. But now I'm going to slide the black over it, and watch the 1s appear on the serial monitor. So as soon as I go over the black, look at that, it's changing to a 1. And then as I slide across it, it changed to a 0. What's even cooler is look at this oscilloscope shot. So I happen to have a portable oscilloscope hooked up on this thing, and let me put it so that you can see the serial monitor. And I'll put the camera over here. Look at what happens when I move from white. So this is the fast discharge, and then it's going to go, here's the long discharge on black, and then back to the white discharge. What's kind of cool is you can put this marker where it's about at 1.4, and you can see that it's quickly discharging right there. And then as I go over to here, it goes long discharge, long discharge right there. And so this is it. It's working. We are able to detect whether we are on a light or dark surface, and we are just looking at it as a digital. You could conceivably look at the discharge rate and try to determine a particular color, because one thing you'll notice is, watch when I go from a white to like a brown, it reflected a little bit more, but it wasn't like a white does, or white reflects everything. Brown reflected some stuff, but it kept some stuff. And so you could actually do a full-blown color detector. Okay, so that's it. Go ahead and make sure that your sensor is on there, and then enter that sketch in there and play around with actually getting this thing to actually work. Okay, good luck. So now we can detect a line on a surface. Okay, so this is great. So let's do this. Let's create a line following program that will allow our BOE-Bot to actually follow a line that's on the ground. Okay, and so we're going to do this with a single QTI sensor, so what you already have on there, and we're just going to do this simple left-right algorithm. So let's think about this. How could you follow a line? Okay, well, we have the ability to detect whether it's white or black. So there's this just most basic way to do this is to try to detect the transition between the white and the black. So when you think about putting a tape on the ground, you're not actually following the line itself. What you're following is the edge of the line, this white-black contrast. And so all you do is you create this program that you're going to move forward left or forward right, and if you're on the white part, we'll have it veer to the left, so light veer left, and then as it goes into the dark part of the tape, you'll veer back right. And so you essentially just go left, right, left, right, left, right, left, right along this transition. And there's a lot of variables here. It's like how sharp do you turn left and right? There's a variable for that. How long do you do it before you sense and stuff like that. And so as you play around with this, you'll see all these different variables, and you'll be able to make a very a more sophisticated, smooth looking movement, or it'll be real jaggedy going back and forth. But it's just a really cool way to get started. Okay, so let's do it. All right, so let me pull up our Arduino Sketch that we have, and this is our I renamed this QTI Activity 1, QTI testing, and what I'm going to do is I'm going to take this and I'm going to add in the locomotion component of it. So let's create a new sketch. So I'm going to do a save as, and instead of calling it let's see here, instead of calling it QTI 1, I'm going to call it QTI Activity 2, and let's do line following. Okay, so I'll go line following. Okay, all right, and so now we got to remember how to do our locomotion part. So we're going to add into here a little bit of servo code. So we got to pound include our servo, and at this point you're probably copying and pasting a lot of your prior code, but I'll just type it in just so that we can walk through it. So I do my servo right and left instances, and then I come down here. I'm going to do testing line sensor or line follower, and that'll tell me the program's running. We're going to play a little tone here. You know what I'm going to do? I'm actually going to play a little startup tune. So what I want to do is I'm going to add something kind of neat in here. I'm just going to go let's go start off with a 500 kilohertz or 500 hertz, and then we'll do a 1500, and then we'll do a 1000, and then we'll do 2000. Okay, just to play four little fellas there. All right, life is good. And now we're still in our setup. We have to set up our motors. Okay, so set up motors. And remember, we need to do a servo left dot attach, and mine are on pin 11. My left is on pin 11. My right is on 12. And now I'm going to do, remember, now we have these subroutines from before, so we got to put them back in here. I'm going to call a halt function, and then I'm going to delay for 1000. Okay. Now we need to copy and paste halt in there. So let's think about that. All right. So now when I come into my loop, what I'm going to do is I'm going to go grab my functions from before, from our previous work, and I'll go ahead and copy them from a prior project, and I'm going to come down after the loop part. So here's our loop, and I'm going to pop these functions, and I'm building up this huge kind of library of functions that sit down here. And so now I have halt. Okay, so great. So now I do this halt, and now it's time to come down and take a look at how we're going to do this. So I set up the motors, and now I'm in my loop. I still want to check on what's going on with the line. So the first thing I'm going to do is I'm going to go ahead and I'm going to output the line. I'm going to turn on pin 2 as an output. I'm going to write it high for 1 millisecond, and then I'm going to wait, then I'm going to wait for a millisecond, and then I'm going to read it. Okay, so now I have this right here, sensor 1, and it's either going to be a 1 or a 0. Okay, so that's what I'm going to basically make my decision on. Okay, so think about this. All we really need to do here is the following. I am going to delete that print statement, and here is where I'm going to do my motion. And I'm going to define two new functions, and I'm going to call them veer left and veer right. So let's type them in, and then we'll see what the code looks like. If I have sensor 1 equal to a 0, that means I'm on the light part of the surface. Okay, and what I want to do is I want to turn left, but I don't want to turn left like a 90-degree turn. I want to go forward left, and so I'm going to call this function veer left, and it is going to be veer left, and I'm going to pass in a time. Okay, so how many milliseconds I'm actually going to veer. So this is going to be 5 milliseconds. Okay, and then if sensor 1 is not a 0, okay, that means it's a 1. That means I'm on the black side of the tape. And so that means I'm going to veer right. So all I do is I say else veer right for 5 milliseconds. And that's it. Okay, so then I just do this, and I put this in the curly brackets, and there's my entire program. Okay, so check this out. I'm in a loop, and all I'm going to do is I'm going to come through the loop. I'm going to read the sensor and determine whether I'm on black or white, and I store this in our sensor 1 variable. And then I just do this simple if-then statement where I say if I'm on the light part, go left a little bit, and if I'm on the right, I'm on the black, go right. And I've created this little function that I'm going to pass in milliseconds. Okay, so the only part left here is we need to go down and we need to create our function for veer left and veer right. And let's do that really quick. Okay, so here's what I'm going to do. I'm going to come down here and I'm going to start a new function. I'm going to call it void veer left, and I'm passing in time as an integer. So I have to do it like that. It's void means it's not going to return anything. And now here I go. And now what I'm going to do here is I'm just going to put in some servo statements in order to move this forward and to the left. And we have all this stuff. So let's go servo left, and then I'm going to do right microseconds, and I'm going to do something above 1500, but I want it to be moving forward, but I want the left wheel, since I'm trying to go left, what I want to do here is I want to have the right wheel moving forward a little bit stronger than, or a little bit faster than the left wheel. Okay, and let me write it like this. I'm going to do 1500, which represents stopping, and then what I'm going to do is I'm going to actually put a plus or minus on here. So I know when I'm moving forward, I'm always going to be above 1500, and so I'm going to put in a number right here that's going to represent kind of how strong I'm telling the motor to go above 1500. And I'm doing this intentionally because I want to start thinking about what I'm adding or subtracting to this 1500 to get it to go. Now my right one, what I'm going to do is I'm going to say servo right, and I want this one to be 1500 minus some number. Okay, so now let's think about this. I want to think about, I'm trying to veer left. I want to move forward but go left. So that means I want my left servo to be moving forward, but I want my right servo to be moving forward faster. Okay, so check this out. What if I did a number right here like 75 and 25? And the reason that I put this plus and minus here was I wanted to be able to really, obviously see which number is bigger. So when I look at this, it's like, okay, 15 minus 75, yeah, that's 1425, and this one up here is 1525. But by putting it as a plus and a minus, I was able to notice that I'm going to basically make the servo right move faster than servo left. And this will become very interesting later when you try to think about, passing parameters in and dynamically changing how strong you veer left or steer right. But I'm just going to type it in like that, and then we'll just rock and roll. Okay, so now let's do our other one, which is veer right. And when I'm veering right, I want my left servo to be moving a little bit faster. So let's do that as a 75, and this is a 25. Okay, so now I've got these in here, and the only other thing that we were missing is we need to have the time. So what I'm going to do is after I set these motors up to do this, I'm going to go ahead and do a delay, and I put time, and that's my variable that I passed into both of these. So I go ahead and copy and I paste that into both. Okay, so I've got these little babies, and let's go ahead and save this, and we will download it. And let me bring up, okay, so I have a typo. I type attached up there. Good thing. All right, so I go ahead and do that, and I'm going to go ahead and say tools, port COM3, switch ports on me when I unplugged. Okay, so it's off and running, and I've got my guy right here, and I have my program almost ready. So testing line follower. Oh, the tone isn't playing here, so I forgot to put delay 500. Okay, so delay 500. Okay, you always got to remember this tone. You turn it on and tell it to do this, but it sets up the port, but then it moves immediately to the next instruction. So they'll override each other and only play the last tone unless you delay. Okay, so now life is good. Okay, so now here I go. I've got my course set up. I've got some blocks back here in order to keep this from running off of the table. Okay, now you hear the tone play there, and I've got it powered up by battery. I've got it in position 1, so it didn't take off. I'm going to go ahead and disconnect the cable, and now I'm going to hit reset and put it onto pin 2. And here's what you're going to go. It's going to go jig back and forth. So there it goes. And look at what it's doing. It is basically going back and forth, left, right, left, right, left, right, left, right, right. It looks horrible, but it is following the line. And I'll put my hand over here to make sure it doesn't. Okay, so here, look at it. It's going. Is it going to make the turn? It is making the turn. It's making the left-hand turn. Here it comes. And now here's the big test. Is it going to make the right-hand turn? And it did it. Okay. Now what's it going to do when it comes off of this? What would it do if it doesn't see a line? Well, it's on light. It'll just sit there and go in a circle. So it's just going left, right? That's what it looks like if it's not on a line. So all it's doing is light left, dark right. Okay. So it's simple. I mean, it's a really simple algorithm, and it doesn't look good. But you know what you can do is you can mess with a bunch of different variables, such as so here, watch this. it's going to turn left, then it'll see the line. And if it comes off of the line, like if you have too sharp of a turn, what'll happen is it'll come off of the line and it won't be able to recover. So I can actually show you that. Let's say that I'm going to try to turn right, but I couldn't quite get it. Okay, so now it's going to take this super sharp right-hand turn, and it won't be able to get it, so it'll come like way off. Okay, so here it comes. And like it came off of the line because it was too sharp, saw a line, and now it's all over the place. Okay. So anyway, pretty cool. So what do you do in order to get this to be more, exact? Well, it's all about these little variables. You think about veer left and veer right. It's how long are you going to steer left and steer right as you make those decisions about this right here. How long are you going to do this before you stop moving and then check where you are again? And then the other variable is going to be down here in your veer left and rear right subroutines. It's how strong of a turn are you taking. And this is, I call it simple because we're doing it with one sensor, and we're not dynamically changing, like we're not saying turn left, oh we're not there yet, turn left stronger, turn left stronger, turn left stronger. We're not dynamically changing the turn, we just have it fixed. And so these are the variables that you can mess with. But we did it. We did this line follower, and it's pretty awesome. Okay, what if what if we also added in the ability to detect an object? So we're following a line and somebody puts something in front of us and the whisker hits it. Wouldn't it be neat if the robot would stop and maybe even play a tune or play a high-pitched squeal? Okay, so let's do it. We have the ability to do this. Now in our program right here, all we have is we play the tone. That's great. We have the motors attached, and we have the QTI sensor set up, and then we have motion right here. So what I want to do is I'm going to go ahead and save this off as a new sketch, and what I'm going to do is I'm going to call it activity 3, line following with whiskers. Okay, and now let's add some code in here to actually detect what's going on. All right, so let us do the following. So I'm now going to come in here, and I gotta remember what the whiskers were on. So remember that when we were doing this, we had to set up the whisker pins, and they were on pin 5 and 7. Okay, so we have to first go in there and set these babies up pin mode wise. So after the tone plays and I set up the motors, I'm going to do let's go ahead and do setup whiskers. And you already know how to do this, but it's nice to remind ourselves. So setup whiskers, I'm going to do pin mode, and on pin 5 I'm going to make it an input, and that is my left whisker. Okay, so that's left whisker. And then on I'm going to copy and paste this. On pin 7, this is going to be my right whisker. All right, life is good. And I've now got them set up, and so now when I come down here, reading from the whisker is really quick. So let's go ahead and let's put it before the actual IR thing. So the first thing is read whiskers. Okay, and remember what we do with the read whisker is I'm going to set up a new variable of type byte, and I'm going to call it W left, and that's just my name. And all I'm going to do is read from pin 5. So digital read pin 5, and all I did was read from left whisker, and then I stuffed it in this variable called W left. So now let's go ahead and copy and paste that, and we'll go W right, and we'll read from this guy right here. All right, and now I've got my stuff. So what do I do with it? Well, check this out. I'm going to come down, and I have these two variables right here, and if they're ones, that means that nothing's touching them. If there's zeros, that means that something was there. I come down, and here is my entire program for Locomotion. It is just doing absolutely nothing but just left, right, left, right, left, right. What I'm going to do is I'm going to, before this entire thing, I'm going to put an if-else statement. I'm going to say if, and right here, I'm going to check the whiskers. So this will be my whisker code. And then otherwise, I'm going to do the left-right. Okay, so I'm going to say if, and what I want to do is I don't care if left and right whisker at this point. I just want to do either or. So let's go ahead and say W left, whisker left, if it's equal to a 0, we had some problems, so something's in our way. Or, and you do a Boolean or using the for a comparison as the double pipe, and so the vertical lines, and so or W right equals 0. And so what this says is that if either the left whisker or the right whisker sees something, then do the following. And what do we want to do? Well, what we want to do is do a halt. So we'll go ahead and say halt. Okay, and then it's like, for how long do you want to halt? Well, let's halt for, I don't know, 10 milliseconds. And the reason that we can do kind of a short amount of time is because it'll continually stay in this loop if something is in our way. But let's also play a tone. Let's play like a tone. Let's play something high pitched, like a really high pitched squeal. I don't even know if squeal's a word. And then so we're going to play that for 10 milliseconds, and then there you go. So now let's think about what's going to happen. All right, before we fire this baby up. Okay. First of all, we read from the whiskers, and we check them first because it's an important thing that we check that there's an obstacle. If there's an obstacle in the way, either on the left or the right whisker, what we're going to do is halt. We're going to delay, and then we're going to play a tone and delay a little bit and let it go. And these are short amount of times. You probably don't even need that halt in there, or that delay 10 right there. If something's out of the way, then you go into the left-right decision. So you veer left or your right. Okay. So let's take a look and see if this works. So I'm going to get my, let's pull up the serial monitor again, and let's take a look at our robot. So now here's our robot, and I'm going to put it back in power position 1 so I can plug it in. I go ahead and plug it in, and now I am going to download it. So I go ahead and say download. Okay, and it is almost ready. And I have it in position 1, so it's not going to take off on me. Okay, so here we go. Plays its tone. Life is good. And now I'm going to detach it. And here we go. I'm going to put it on position 2. I'm going to hit reset, put it on position 2, and now I'm going to go ahead and do it. And I'm going to put a book here so that I can see what's going to happen. Okay? So here it goes. It's following the line, and let's see if this works. There it is. And it's making this horrible 6 kilohertz sound, which it can barely even pump out. Okay, so look at that. Move that away, put it down here. And it's good to go. Okay, so awesome. So we did it. So it's cruising along. Everything is good. Let's get this baby back so it kind of ends at the same spot. And there you have it. So there you have a line follower with object detection. Okay, very good. Now you give it a shot.